Hi, my name is Shripurna and I'm the founder of Arctus Aerospace. We build unmanned aircrafts that fly at 45,000 feet for 24 hours at a time. They can carry around 250 to 300 kgs of payload, and what we do is primarily Earth observation. We can do persistent real-time video from the sky at extremely detailed resolution, which we sell off to commercial customers.
Hello and welcome to The Print. My name is Soumya Pillai and today I'm in Bangalore to bring to you a unique story of a 23-year-old founder of an aerospace startup which is redefining the concept of Earth observation. Stay tuned for this ground report to get a profile of the company and the founder. I'm joined by the founder of Arctus Aerospace. He's a 23-year-old who has big dreams of building an entire industry of Earth observation through aircrafts and not space missions, which is going to significantly cut down the cost of Earth observation as we know it. So we're going to be in conversation with him. Thank you for joining us at The Print, Shripurna. Could you tell me a little bit about what the vision of Arctus is and why do you want to do this differently from what we are already doing right now?
Yeah, thanks for having me. But like the way we look at it, the company did not come out through like looking at breaking Earth observation, but it was a very interesting solution. It's a very unobvious solution to a problem that is still persistent right now. So because if you look at the market right now, a lot of Earth observation companies exist, but majority of them are primarily payload makers and not satellite makers, because all of these companies specialize in one particular kind of imagery and then they use satellite as a medium to capture those images. Now commercially we have seen only two sectors take off per se in this. It's either these small drones like quadcopters or multi-rotors flying at the altitudes of 500 to 1000 feet depending on what your use cases are, or it's satellites, and there's nothing in between. Now satellites have the advantage that you just put them up there, they stay there for 3 years and then you can just collect it. There's no cost of operation once deployed other than just collecting data. But the issue is one satellite doesn't make economic sense. You need to put a bunch of satellite like a constellation in order to do persistent Earth observation to have any sort of commercial viability. Now with drones, there's a different whole use case, different whole problems and features it has. Feature being, since it's low, you can get good resolution, you can get videos, you can do a lot of detailed inspection. But the cons are it's flying low. So if one motor fails, it'll crash into your infra, and that's why we haven't seen a lot of observation, EO done by quadcopters going mainstream. And not only that, the endurance of these, the SWAD, and a lot of issues come into play. So we were not looking at the middle ground of this. We were actually primarily looking at defense and like looking at what is like a very hard technical problem to solve first, because for me personally that's like has been a motto in life. We need to have problems that we need to have products that are technically superior and like they're hard to replicate. Then you can build a whole business around it, and that was what's alluring me, and that's why defense. There are a couple of products in defense which are like, although a lot of people have tried to solve it, a lot of people have tried to build products like that. There are only like 6 to 7 companies in the world who build like medium altitude, long endurance UAVs, which is the product which we are using, and we are making it commercially viable for other commercial customers to use this kind of aircrafts. Now, these aircrafts find like the best of both worlds. We don't need to be everywhere all the time commercially. We have our customers, so we just need to be monitoring them, collect data for them, inspect for them. And our business is not in the sale of aircraft. This aircraft is just a medium to collect data. We sell data to our customers, and that is how we came across this.
Shripurna, we're going to get into the products that you are developing, the
Yeah.
aircraft that you're developing. You know, you have 3 phases in which you'd be developing it. But before I get into that, tell me something about yourself. You're 23, you're an engineer. How was your childhood like? Were you always interested in building things, so to say? How did you get into, building this startup?
Yeah, I'm from a small town called Surathkal, and my house is close to NIT Surathkal. So pretty early on in my life, I knew what engineering was, being surrounded by engineering institutions. But I have always been fascinated by space and aircraft. They are they're more like magic to me, because if you go 100 years back and tell humans that, look, we took something from ground, we beat it up with something, and then it carries you and flies, and you can go anywhere in the world. That is magic, and that's what engineering is. So that actually captivated me pretty early on, and I actually built my first like RC aircraft, like the one which people fly around in like aero clubs of colleges. I built it when I was in like seventh grade in school, so that's 13 or 14 years old, and I've been in love with aircraft ever since then. I wanted to do like aerospace engineering, but then my JEE rank was not that great. Like I missed it by like maybe 1-2 questions. But looking back, I mean, I would say everything has turned out well. I went to IIT Madras. I did civil engineering there, but I chose IIT Madras primarily for its deep tech ecosystem. And yeah, I mean, even there was like core team member at the aerial robotics and aero modeling club. We brought in the discipline of building like aircraft, because a lot of these aero clubs primarily are experts in like multi-rotors and quadcopters drones, but not RC aircraft. So like there's not much aero modeling happening. And when I say aero modeling, like fundamentally understanding aircraft, building new structures, uh, doing like R&D there, and that didn't exist a lot. And I brought in with a bunch of my college friends, and yeah, in final year of college started Arctus, and it's been a great journey.
So, Shripurna, just for my understanding and for our viewers, what you're doing right now is essentially the first time that anybody is doing such a thing in India.
Yeah.
And also, globally, you are among the very few companies who are already doing it.
Yeah, so we usually try to avoid comparing benchmarks and be like the world's first. We don't believe in that as a company, but we are the first ones making a platform like this commercially viable for commercial players. And and the way we do it is we build the whole aircraft in house, because there is kind of a monopoly on these kind of aircraft, on good ones. Like, so there are like 3 companies in US, couple of them in Israel, Turkish are not there yet, but yeah, they do have platforms that can do like for defense, and all of these guys sell for defense, and there are massive markups in premiums if you want to buy this aircraft. And we were like, if we could build this, and if we execute the way we see our vision to be, commercial earth observation through aircrafts are going to be much bigger than whatever defense can ever be. That's pretty counterintuitive for people, but the economics say, like the numbers say that. And we will also have a capability to build these kind of aircrafts in house, and that is in a way a strategic asset, because aircraft building is completely different from what people traditionally think any of these unmanned aircraft platform development is. Drones are pretty easy to build, they're pretty commoditized, but these are not. These are firstly a hardware problem, and on top of it a software problem, on top of it an autonomy problem, and on top of it like lifetime. You can't use this aircraft once. We need to have like, we are designing it in such a way that we should be able to land and take off these aircrafts 1 lakh times. That means if you look at our endurance, that's 2.4 million flight hours on a single aircraft before we have to do any major upgrades on it. We are designing it from that lens. And yeah, that's how we are in a way the first ones to commercialize this kind of platform. And a business makes it pretty simple for our customers as well. They really don't care how you collect data. The only thing they care is the value from the data. And we can, since we are flying at 40-50,000 feet, we can literally zoom in and see how your contractors you're working with are following SOPs or not, collect data for you so that you can build models on it. Like there's a lot of applications that gets unlocked because of a platform like this. A platform like, earlier you couldn't do these kind of things. The unlock was not there. We are like creating a new kind of data in the market, and that then enables like a next $100 billion market creation opportunity for us. And we are in the business of market creation. My engineers have left the switch on, so anyone can come in and just play with it if they want. So this is like a test rig which we built for testing landing gears. So when landing gears, so to give some context, the second prototype has 200 kgs of like takeoff weight, 210 kgs actually, and when it lands it needs to take those impacts. So we build this rig where we lift it up, and then we have a drop mechanism where, like, right now this is I think 100 kg load which drops, and you can do impact testings of your suspension, your landing gear, the whole setup. And this whole rig actually is built to lift the whole aircraft up and drop it, and do like a bunch of like loading tests, static, dynamic, all of those can be done with this. So the way we go about building this product is we have divided this whole game plan of ours into three products. First two being experimental, and the first product is basically a 2 to 2.5 meter wingspan aircraft flying at 10,000 feet. They can stay in the air for 3 hours, and we put a couple of small optical payloads to actually validate the thesis of like Earth observation through platforms like this. And what we have here is the first model where this is a completely 3D printed aircraft, and on top of it, it is integrated with sensors throughout the body, which helps us build our own proprietary flight stack in a way. So the way we look at it is we need to control every single aspect of like the development of aircraft in order to make any good platform the best platform out there. So we are not buying a lot of components off the shelf. What we do is we design them all by ourselves and we send it out to manufacturing just for us. These are custom built, like even if we talk about the electronics that goes on top of it, like the flight computer, the embedded systems, the sensors, all of these have been designed by us. Even the servo motors, a couple of them which we use on these aircraft are manufactured by us. Like we have vendors who manufacture. It's very expensive to do it. It's not like usually the obvious way for people to go about it, but it helps us understand what it takes to build autonomy on a platform like this. And this is actually like flight tested. We have around 200 to 250 flight hours without incidents, by the way. We have built like more than 20-30 models of these. We have been doing, this was the first prototype which started the company off in a way. We first built like the fuselage. Once we mastered that, then we went into the electronics, and we took one step at a time so that we can learn what it takes to build complicated system integration platform like this. And we use this platform to validate a lot of our Earth observation thesis as well. We captured a lot of images, and these are like not fancy cameras. We just used like anything off the shelf available optical cameras to capture video from the sky, and that where we could see people driving on bikes, whether they had helmets or not, and stuff like that, and from 10,000 feet. So once we validated that, now what we have done is we are building a bigger platform somewhere in the ballpark of 7.6 to 8 meters in wingspan. Now that aircraft is gonna fly at 20,000 feet. It can stay in the air for 10 hours, so endurance of 10 hours, and it can carry 55 kgs of payload. And that right now is under construction. That's what we're manufacturing right now. And there, every single part of the aircraft other than the engine is built by us. And we literally hand built it with our hands in a way. And that is a test platform that will help us get to the final product, which is the aircraft that flies at 45,000 feet, 24 hours of endurance, and 250 kgs of payload. Now, this is the way we have developed our product development timeline, and we are already at product 2, the experimental product 2, which flies at 20,000 feet. Yeah.
What is the final product?
The final product wingspan is going to be somewhere in the ballpark of 18 to 20 meters. It's the weight of the aircraft will come somewhere between 1.2 to 1.4 tons. So, and yeah, rest of the features, 45,000 is cruising altitude, 55 is like the flight ceiling, 250 kgs of payload, so you can put anything on that, and 24 hours of endurance with the 250 kgs of payload. That is how it is.
When do you plan to launch the final product?
Yeah, the final product, the first prototype will be ready by this year end. We are already on it actually. We have learned so much building this and the second aircraft that we already started the R&D, early stage R&D process, and like the preliminary design. Actually, we have completed preliminary design at this point of time, and we are going into detailed design right now. So yeah, the first prototype flight ready by this year end. We are looking at that.
Arctus Aerospace and Shripurna are out there not just to redefine what aerospace startups are doing in India, but also redefining research and development that's happening around the space of Earth observation. It'll be interesting to track their journey through the year until their final product finally comes out to see how this is going to perform and how it's going to change the industry. You were with me, Soumya Pillai, for The Print.